We want to move on to the topic of inverse functions, but in order to talk about inverse functions, we first need to define what a one-to-one function is. A one-to-one function is defined this way. We say that a function is one-to-one if for every y value there is only one x value. Now, I know as you hear that, some of you are thinking, wait, I know that definition. That's just the definition of a function. That is like the definition of a function, but with x and y switched, and it has a very different meaning. It is true that something is a function only if every x value maps to only a single y value. But what we're saying is that every y value can only be reached from one x value in order for the function to be one-to-one. What I mean by that is this. If I draw in a couple of different x values along this top function. You see I've marked these two graphs that I've drawn on the right. The top one is a one-to-one function. The bottom one is not a one-to-one function. If I start marking in the y values corresponding to these tick marks that I've drawn on the x-axis, what we'll see is that I get a different y value for every x value that I put in. So we can see on that function is that every y value can only be reached by one x value. Every given x value maps to a different y value. On the other hand, if I put in, let's say, that x value and that x value, what we'll see is that these two actually map to the same y value. So that's why the function on the bottom is not one-to-one. One way to think about this is that if I draw a horizontal line across the function, I actually intersect the function in two different, I intersect the graph of the function in two different points. When that happens, you know that you don't have a one-to-one function. That leads us to something called the horizontal line test, and I'll just very quickly write that. So this is the horizontal line test for whether a function is one-to-one. We say that a function is one-to-one only if every horizontal line intersects the function in at most one point. So we see it's certainly possible to draw a horizontal line down here that intersects the graph in no points at all, which is certainly less than one point. And it's also possible right at the bottom at the vertex to draw a horizontal line that intersects the graph in exactly one point. But that's not the issue. The point is the function is not one-to-one unless every single horizontal line that I can draw intersects the graph in only one point. And it's clear that up here I can draw horizontal lines that intersect the graph in 2 points, and therefore this function is not one-to-one.